Okay, welcome to lesson 4. So we're working on the skills. This is part 2. Skills part 1 was looking at finding the zero. So today we're going to be finding the vertex. 3 points, three ways to do that is by completing a square, by finding the midpoints of 2 points at the same height, and that's usually finding the midpoints of the zeros. There is another strategy where you can find the midpoints of just 2 points. We're not going to focus on that today though. The learning goal is finding an equivalent expression of a quadratic. So changing the expression of from standard form to vertex form, and then to actually determine the max and minimum. And so what we're going to be working on, you've already kind of worked on developing the plan, what you need, but we will be talking about that. But also just determining max min from factor form and max min from standard form. This partial factoring is actually not going to be hit here, but it is kind of a neat concept. We're going to focus today on completing the square. So just to start, you can actually find the vertex of these three if you want to pause it. If it's in factored form, you can state the zeros. So if you know the zeros are 3 and 5, the vertex has to be between them. And so if the vertex between 3 and 5 is 4, if you now sub in 4, you can get the y value of -1, and so your vertex is 4, -1. The second one is actually in the form, in vertex form, so we can actually just sub in. The easiest number to sub in is actually 4, and you get -1 out. And that's the 0, 0 vertex shifted to the right 4 down 1. And so the second one, with transformations, we know that the vertex at 4, -1. And the third one is in standard form. And so if you actually factor it, it can factor pretty nicely, and then it's the exact same as the first one, where you can now state the zeros and find the vertex. So these are all great ways to find the vertex, and none of them require completing the square, but today we are going to focus on, okay, so if you don't have something like this that factors really easily, or is already factored, or is already in vertex form, what do you do? And so we're going to start with a question like this, and so to focus on getting from standard form to vertex, we actually start with something it's not in standard form. It's in the form that it's in is actually up for debate. So you can say that this is in vertex form, or you can say it's in factored form. And that's the form that we actually love. We love it that if it can factor to something that looks like this, that's actually in vertex form. So the vertex is just at 2, 0, and we imagine that there's a little +0 out here. If you sub in 2, you get 0. And it's also just shifted to the right 2, no up or down. The second one factors nicely. So it factors to x minus 3, x minus 3, which is x minus 3 squared. And same thing, you can easily kind of extract the vertex from there and just say it's 3, 0. The next one, what we do is we actually create what we have in the second one. So we want to make use of that idea of factoring it nicely. And so you can factor this as a common factor. And that's actually a great way to find the vertex. You get 0 and -6. 0 and -6 to find out where the vertex is. But we want to take advantage of the fact that if this thing had a little +9 on the end, it would actually be a lot similar to the second one. Not the same, it's got a plus in the middle, but very similar. You just can't add 9 to something, though. You're not allowed to do that. So if you add 9, you have to subtract 9 right away. And it's the subtract 9 that we just kind of leave off to the side. And if you want to push it away so that you don't play around with it, you actually leave it off to the side. And so what we factor this to is we factor that trinomial in the middle there as x plus 3 squared, x plus 3 times x plus 3. And then to get the vertex, we're just shifting left 3 and down 9, and so the vertex is at -3, -9. And this is what we actually call completing the square. We could do something like this, and so recognize that we don't actually want +9 on the end. That's not what makes it factor nicely. We actually want the number we want this to be on the end, so it factors nicely, is actually +4. And so we take this little part here, the x squared minus 4x, just on the side, and we won't do it on the side in the next one, but just to show you, we take the x squared minus 4x, we add 4 and subtract 4. So that's the completing the square step. Why 4? Because that will allow you to factor it to x minus 2 times x minus 2. That's the only number that'll work, and there's only ever one number that works for every middle number, every negative, like every b value. And that works nicely like this, x minus 2 squared minus 4. And then the little plus 9 on the end, we actually just leave it again on the side, and now we put it together with the minus 4. That just shifts everything up 9 from the minus 4. And so this part here becomes this part here, and then we have a little plus 9 that's just going to stay on the outside all along, and we can put it together and get plus 5. So you can see your vertex now is at 2 comma 5. So when x is 2, y is 5. Don't get caught in memorizing vertex form as like, oh, it's the number, this number changes signs and this number stays the same. Don't get caught into that. If you sub in x is 2, you get y is 5, because this becomes 0. So this strategy will always work as long as the a value is 1. But if the a value is not 1, what we do is we take the a value out. Even if it doesn't factor nicely out of the b value, we just force it out by dividing. So you can have a decimal, and we'll do a question where you have a decimal. This plus 5 just stays on the outside all along. And so we're going to leave that plus 5 on the outside and just factor the 2 out of the x squared and the minus 4. So you don't have to force it out of the 5. You don't want to, like, you just want to look at this part. And now what we do is complete the square. So we add the 4 and subtract the 4, and it's very similar to this here, but it's inside the bracket. It's really important that you put brackets around it so you can work inside. The 2 can be distributed to the negative 4. It's got to be distributed to them all, but like for now we're just going to get rid of that negative 4 so that we can just have like a trinomial here. And so we've got negative 8 plus 5, and that's going to end up becoming our number on the end. The middle part, the middle trinomial, just factors. Like we saw before, it's x minus 2, x minus 2. And that's the completed square. It's a perfect square, so it'll factor the same thing. And we should expect that to happen because we created that. We put that plus 4 in there for that reason. And so then we're actually done. The minus 8 and plus 5 is the minus 3, so your vertex is at 2 comma negative 3. So this is your completing the square. That's the full solution with an a value. So the question is, how do you get that last term? And so that last term, like when you have a quadratic in this form, it's a perfect square if you divide b by 2 and square it, and you get c. So like if you look at this kind of idea here, if you take out the a, then you've basically got the same thing. It's just like we could call this b over a, but that's the form that we actually want just by factoring it out. B is probably not the right letter to use there, but that's what you want. You want to get it in that form. And so you need a perfect square in that middle there. And so you get that by cutting b in half and squaring it. That's what will always work. Because like you're adding, when you expand it out, you're adding that number twice, and you're to get the middle term, but you're also, and that's going to be the b over 2 part, but you're also multiplying that number twice to get the c value. And so that's what we're going to be focusing on, is b over 2. So remember the golfer, if we want to get this form, find the vertex, we could totally do this by factoring, like we did before. And so we got 10 and negative 2 as your factors, are your zeros. That's when height is 0. You get the vertex by finding the midpoint. The axis symmetry is right in the middle of 10 and negative 2. If you add those and divide by 2, you get 4. So if you look at it, like, it makes sense that that's 4. It's 6 away on both directions. Now if you sub in 4, you can get the vertex at 180. And so you realize that this thing's only going to go up to 180, so it's not going to hit those power lines. Okay, you can see the visual here. It's only going to go up to a height of 180. This orange line is at 185. Another solution is to complete the square. So if you've got this, you can take out the negative 5. Don't take it out of the 100. You don't need to. Leave the 100 on the outside. So divide positive 40 by negative 5 to get negative 8. We complete the square by dividing 8 by 2 and squaring it. So 4 divided by 2 is 16. This number will always be positive. That's the nice thing about squaring. Kind of like in the quadratic formula, when you square it, it always becomes positive. So if you add 16, you got to subtract 16. You can get rid of that negative 16 by distributing it. So you get plus 80. And that's where the 180 is going to come in, right there. And then the middle part, trinomial can be factored to minus 4. And so you get t minus 4 squared. So your vertex is at 4 and 180. When you master completing the square, it's actually a nice skill. And you can see it's actually even maybe shorter than factoring it and finding the zeros. Some people like it better. And you can see that the max height is going to be at 4 and 180. Again, so we're going to try this one like with fractions and decimals. And so if you like fractions, I encourage you to challenge yourself with fractions. They're good for higher level math. But if you're not comfortable, you just want to learn the skill of completing the square, then you're free to use decimals as well. So with fractions, we do take the 3 out. So we got 9. That's not where the fraction comes from, but it could. We half that term and we square it, and so we get 9 over 4. So half of 3 is 3 over 2, and then squared is 9 over 4. Then we subtract 9 over 4. With decimals, so 3 over 2 squared is 9 over 4. With decimals, you get 1.5. 3 over 2 is 1.5. Squared is 2.25. And that's the same as 9 over 4, 2.25. Distribute the 9 over 4, or the 3 to the negative 9 over 4. So you get 3 times 9 over 4. Distribute the 3 to the 2.25. You get 6.75. And then factor that middle term to half of the 3. So the thing that multiplies to 9 over 4 is 3 over 2 times 3 over 2. And that's the same as like half of 3. 3 times 9 over 4 is 27 over 4. 2 is 8 over 4. So I just found the common denominator right away because I knew that I'd need this thing over 4. Over here you get 1.5 and 1.5, and then you can just put these together. It saves you a little bit of work doing the decimals because you don't have to worry about the common denominator. And then just put it in vertex form. So plus 3 over 2 squared, plus 1.5 squared, and then so you're going left 3 over 2 and down 19 over 4, or left 1.5 and down 4.75. Finally, we go back to our riders question. So we've developed a plan for this, and the plan consisted of creating that equation, deciding I need to find the vertex of a quadratic. My equation is going to be based on 2 linear equations, so y equals b minus mx or b plus mx. The revenue that we're going to maximize is this factored form, price times quantity, and that's actually going to come up later because we actually want to know the price and the number of riders. And so it's in factored form. We're not going to complete the square. Like a lot of people like expand this and then try to complete the square. But you actually have it in factored form. You can find the zeros. So the zeros are going to be negative 20 and 28. And so the midpoint of the zeros is going to be 4, because 8 over 2 is 4. And then if you sub in 4, so you realize, connect it back to the question that 4 is the price increases. So price increases of 10 cents. So we're going to raise the price by 40 cents. So we're going to end up with a $2.40 wage. And we're going to lose 8,000 riders. So we're going to have 48,000 riders. The price and the quantity are right there. And then if you wanted the maximum revenue, you could just multiply them together and get the 115, 200. There's some homework.